right, this is the 09B work and power. That is the topic for this week. The objectives for today are to understand energy transformation and energy change. And we're going to understand conservative and non-conservative forces. The agenda for today, we're going to do the lab, the destroyed energy lab. Then we're going to talk about energy transformation versus energy change. Then we're going to talk about conservative versus non-conservative forces. Now, just check my introductory videos for all the announcements on the assignments and the any other additional announcements. So the big question for today is, why doesn't the Newton's cradle go forever? All right, so remember there are codes in the videos. There's one written code. There's another verbal code said by myself. Each code will be 3 numbers. You need all the codes in order to move on with the homework assignment. And for the note-taking instructions, just write what is in green. You will need these for your notebook check. So at that time, this is the video 09B written code. It's 175. I would recommend writing that down somewhere. All right, so we started off with we're going to start off with the destroyed energy lab. So that's how we're going to start off that day. Then we're going to talk about energy change versus energy transformation. So when energy changes, the total mechanical energy will increase or decrease. Now, when energy transforms, it transforms from kinetic to potential or potential to kinetic, but the total mechanical energy does not increase or decrease. So this video shows sort of like the demo of like different or the same metal ball bouncing on different surfaces. And should be able to say that, well, energy is transforming when that ball is dropping. It's going from potential to kinetic. Now, when it hits it, some of that energy gets changed into heat. It goes off into the external world. That's what I like to think about that. Now, why doesn't the Newton's cradle go forever? Well, energy transforming. We sort of learned about a pendulum, but this is similar to a pendulum where energy is going to be transforming when, well, the ball is going to be swinging down. So it's potential to kinetic, potential to kinetic. However, energy is going to be changing when those objects hit together, and some of it gets turned into internal energy. Some of it goes into like the string with that tension, right? But overall, some of that, you're shedding some of that energy to the outside world gradually. Same thing with a ball dropping over and over again, right? So energy transforming would be, well, going from potential to kinetic, potential to kinetic. Now, when the ball hits the ground, or for air resistance, it's changing that energy into heat or sound, and it's going off into external world because it's lowering that mechanical energy. So what's going to do that is conservative versus non-conservative forces. Right, so this talks about, this video really shows the conservative versus non-conservative forces. Now, conservative forces, they transform energy. The energy is stored somewhere in a field. It's path independent. Examples of conservative forces are gravity and the spring force. Now, non-conservative forces, they change energy. The energy is dissipated as heat, sound, internal energy, etc. Path dependent. Examples of non-conservative forces are friction, and mostly all other forces are going to dissipate that energy. So in class, we do an example with a volunteer. So let's just look at something like this, like a person skiing. Well, what force is pulling the slider down the slope? Well, it's going to be gravity, right? Now, is it a conservative force or non-conservative force? Well, it's going to be a conservative force because, well, notice that as that person is going down the hill, the total mechanical energy, that green bar, does not change. Right? So notice that the green bar does not change. Now let's look at that bottom one. Is the energy of the skier transforming? So it's going to be transforming. Right? Because conservative forces transform that energy. Now the force that's slowing the slider down will be the frictional force. Now that's going to be non-conservative because notice what happens as that slider hits that unpacked snow. Well, it's changing that mechanical energy. The mechanical energy is lowering. All right, good. All right, so that is going to be the links for the day, and I'll give you the verbal code. The verbal code for 09B is 181. I say that again, the verbal code is 181, and I will leave you with this. Remember, there's just too much unknown in the universe to take a break from learning. Get out there and question everything.